Okay, so good afternoon, everyone. I welcome you back to my YouTube channel. Presenting before you this tutorial is Hampeyo Klima. So we have this practice question, and it's saying we let R be the universal set and D equal to 7 exclusive, then 8 inclusive, then we have E, the set of 0 to 11, then we have the F that's saying uh, it is the range from negative 10 up to from negative 10 to 10, and then we have been told that where x is a member of all real numbers, and then we have been told that all the sets D and E should be the subsets of x. Then we find the set F slash E complement and display it on the real line. So I think people had quite a lot of challenges solving questions that involve De Morgan's law. Well, they are quite simple, so I'm going to show you just how to solve this particular question. Let me just get my board. So the first thing to do, of course, is to draw the real line. Okay, so we know that we have been told that we let R be the universal set. R is a set of all real numbers from negative infinity to positive infinity. So we are going to draw our real line here. This is going to be our real line. Okay, this is going to be our real line, like that. And then we're going to have negative infinity here. We're going to have positive infinity here. Then we know that we have negative 10. We know that we have negative 7. What else? We know that we have 0. Okay, we know that we have 8. What else do we know? What else do we know? We know that we have 10 here. And then we know that we have 11 here. Okay, so we now see how we can solve these questions. Okay, so we've written our R, which happens to be the set of all real numbers, and then we can now plot everything out. We can write our D set, and to write D set we are going to put it like this. So we are going to have an open circle at 7, and we are going to have a closed circle at 8. Okay, like that. Then we go to E. E is a set from 0, but 0 exclusive, so it's going to be an open circle here, and then we are going to have a shaded circle here. So that's going to be an open circle again. And then F is a set from negative 10 included, so this is negative 10 is going to be included, and then it is going to go all the way to it was supposed to go all the way to 10. Okay, so this is supposed to go all the way to 10, so I'm going to take it all the way to 10, like that, included. Alright, so we've written everything out. We can name them. This was our D, then this was our E, and this set was our F. So the first question is saying we find the set, we prove that we find the set F if we find the set F, okay, they're saying F slash E complement. So we are going to go on our real line. We are going to go on our real line, and then we find E complement. So E complement, we're going to have some shaded region here all the way to negative infinity. So like that. Even here, because there's an open circle, it is going to go all the way to positive infinity like that. Now the question was saying we find a set of everything that is in F which is not in E complement. So we know that this is E complement, this is E complement. So this is set F. So we check where set F does not contain E complement, then that is going to be our set. So starting from this region here, okay, starting from this region here, okay, up to here, this region here is a set F. This part is a set F which is not in E complement from this side, at the same time this side. But we know that 0 is part of E complement, but it is also part of F. So meaning we are going to put an open circle at 0, then we're going to put a crossed circle at 10. So this particular set is starting from 0 all the way to 10 included. Okay, so it makes sense. But if you want, you can solve it this way. You have your F slash E complement. This can also be written as F, the intersection of E, complement, some complement. So F intersection, what is complement to a complement? Complement exposed to a complement, I said last time, I said it gives you the set. So we find where the two are intersecting. The two are in E and F are intersecting at this same region. And this proves that our answer is correct. Okay? But notice that we want to find the intersection of F and E. 0 is part of F, but it is not part of set E because there's an open circle. Henceforth, we are going to put these brackets. But 10 is part of E. It is also part of F. Henceforth, we'll put these brackets. So you can also solve it the same way. It is going to give you the answer. We go to the second question. The second question is saying, using the set above, verify that D complement intersection E complement, D complement intersection E complement is the same as D, the union of E complement. So we are going to say this is going to be our left hand side and this is going to be our right hand side. There are two ways of solving this and we use De Morgan's law. So let's start with the left hand side. So we have D complement. Okay, we have D complement and then we are intersecting it with E complement. Okay, D complement intersection E complement. Okay, so let's try first of all to go on the real line. Okay, so we can wrap some things from there. All right, so we just wrap some things. Like that. So let's find D complement. D complement is a set from here. Let me use another pen. Okay, so D complement is going to be a set from here up to this particular end. This becomes our D complement. Then here we have an open circle all the way to negative infinity. Now we find the intersection of these guys. So E complement is intersecting with D complement on the left handed side from here up to negative infinity. Then this side, it is from, this is D complement. So they are intersecting from here all the way to this side. So these guys, if we solve them, it's going to be a set which is going to come all the way, that's going to be a set which is going to come all the way from negative infinity to negative 7. Okay, then the union of, let's check, 11 was part of E, 11 is part of D complement, so all the way to 11, then all the way to positive infinity. That is our left hand side. Let's try to prove the right hand side. So right hand side, we have D union E complement. There are many ways of solving this particular question, but we can say that this can also be written as D complement, and then we can say we distribute the complement only to the letters, to the sets given. Okay, like that. We can use the union. We see what's going to happen. Okay, so D complement, what is D complement? D complement is a set which is coming from negative infinity. It's here, a set which is coming from negative infinity, and then this set, we have been told that it's going all the way to negative 7. Negative 7 excluded, negative 7 included. Okay, so negative 7, okay, sorry, since negative 7 is part of D complement and is also part of E complement, we were supposed to write a closed circle on negative 7. Okay, here there's supposed to be a closed circle like that. All right, so even here there's going to be a closed circle, then the union of, and then we have been told that from the diagram, where is D complement is coming from 8 all the way to positive infinity. So it's going to come from 8. Was 8 included? 8 is not included. So it's going to come from 8 all the way to positive infinity. Then E complement is a set which is going to come from, E complement is coming from negative 11. Okay, it's coming from negative 11 like that. It's coming from negative 11. Sorry, it's coming from 11. Sorry, positive 11. Sorry, E complement is coming from negative infinity to 0. So negative infinity all the way to 0 is 0 part of E complement. 0 is part of E complement. So we have our 0 here. Okay. So we have the union of, and then we have been taught that E is starting from 11 like that, then all the way to positive infinity. But then from what I've solved, I don't think it's going to hold this way. So let me try another way. Let me try to use another concept. They must be able to be equal. It's De Morgan's law. What is on the left-hand side should be equal with what is on the right-hand side. So okay, so what I'm going to do is this. I'm going to work out what is in the brackets before, because if I distribute the complement, I was supposed to change the union set. We know that. So let me work out what is in the brackets first. So what is D union E? Let's go on our set. D union E. Where is D union E? So D union E is this particular set. This set here, we can name it as D union E. Okay, so we can say that. Sorry, let me just. Okay, so first of all, work out what is in the brackets. So we can say we work out D union E. So D union E, we know that is a set from, it's a set from negative 7 all the way to 11. Okay, 7 all the way to 11, but we know that all of them are excluded. So it's a set from negative 7 all the way to 11. Like that, both of them are excluded. Then we find the complement of this. So I'm going to use the blue pen. Let me find the complement of this. So I'm going to write a cross circle here all the way to positive infinity, and this is going to be my, it's going to be my D union E. Okay, complement. Then I will go here at the far end like that. I'll also write a close circle, then I'll take this side like that, and that is going to be my D union E complement. Now check properly. D union E complement, what set are we getting? We are getting a set which is coming from negative infinity all the way to 7 included, union, then a set from 11 included all the way to positive infinity. Let's see if what we have there is what we have on the other side. Okay, so if we find the complement of that, we are getting, let me see, what did we get? We got a set from negative infinity to negative 7 included, the union of Okay, 11 all the way to positive infinity. Okay, so we've discovered that this was our left hand side and this is our right hand side, and we've proved that actually D complement intersection E complement is equal to D union E complement. Okay, this is De Morgan's law. So it's very simple to prove. Very simple to prove. We get to, they're saying, what about D complement intersection E complement intersection F complement? Is it equal to that? Okay, so we have D complement intersection E complement intersection F complement. Is it the same as D union E union F? Then they say complement. Is it okay? So let's try to prove. So to prove this particular one, we will go on, we'll first of all write our F complement. So it's going to be an open circle all the way in this direction. It will also be an open circle here all the way in this particular direction. Okay, then we find where they are intersecting. So we know that all of them are coming from negative infinity, but this is F complement, this is F complement. So on this side, these guys, let's see where they are intersecting. Okay, so we see that these guys are intersecting at this region. Okay, we know that this is E complement, this is E complement, this is F complement, E complement, intersection D complement. They are intersecting at this region here. Okay, so we've seen that these guys are intersecting at some point where we're coming from negative infinity all the way to, okay, so this side they're intersecting at, okay, so D complement intersection, let me just write that. These guys are intersecting from negative infinity all the way to negative 10. Was negative 10 included? Negative 10 is not part of the complement, it's not part of F complement, so it won't be included. Okay, then let's check on the other hand, on the other end. Okay, so on the other end we have something which is coming from here to positive infinity, but 11 is part of everything. Okay, 11 is part of everything. It's part of D complement, it's part of E complement. Okay, it is part of E complement. At the same time, it is also part of F complement. So it's going to be the union of then 11 all the way to positive infinity. Okay, then let's try to prove that. What is D union E union F complement? So first of all, we cut what's in the brackets, D union E union F. So this is going to be a set. So this is set. Okay, so this is going to be this set. If we combine, let me use another color, pink. Look, this is set D. Okay, this is set D, this is set E, okay, this is set F. They are saying, first of all, we find the union of everything. Let's find the union of everything. So the union of everything is going to come from here. Okay, all the way to where E is going to end, like that. This region here, okay? So it will be this set. This is this is the set F union E union D, which we are looking for. You just will need to be a little bit careful when highlighting this, okay? So this is the set when we combine set F, set E, set D. Now we find the complement of this set. The complement of this set is going to come from here, okay? But it's going to be an open circle because here at F there was a cross circle. So it will be an open circle here. Then where everything is ending, okay? So here there was an open circle. There was an open circle at E. So this time around it's going to be a closed circle, okay, all the way to positive infinity. So what set is that? When we combined everything, we were getting this particular set from -10 all the way to 11. That's the set that we got, okay? So this set was from -10 all the way to 11, okay? That's the set that we got. Now we find the complement of this set. To get the complement of that particular set, D union E union F complement is going to equal to, okay, so we are following the complement which is from -infinity, okay, all the way to where is the union starting from? The union is starting from this point all the way to -10. -10 won't be part of this set, okay, all the way to -10 union of, then why is it ending at this point? But we put a closed circle to find the complement because here there was an open circle. So starting from 11 included all the way to positive infinity. And if you check, what we have here is also what we have here. Henceforth, the set D complement intersection E complement intersection F complement holds for this particular set. And it makes sense. Thank you so much.